Today is the 19th. We are. And we are going to just continue the notes from yesterday. So we're still talking about properties of exponents. So I have more examples. Assuming you were here yesterday, you already got those. Assuming you weren't here and of course you watched the video, you've still got them. So let's pick it up where we left off. You're going to start seeing more complex looking problems. So you'll see each of these gets a little bit more intimidating looking as we go. And I do have some steps for you. I'll write them down probably later. Or maybe I'll type it up and give it to you as well. I don't know yet, but there are like some rigid steps you can follow. But for now, I'm just going to kind of talk you through the process. So here are our examples. Well, at least here's our first one. We have a fraction, okay? And on the top of the fraction, we're going to have 6x to the negative fourth, y to the third. And on the bottom, we are going to have 8x squared and y to the negative fifth. So later on, in a few minutes, a little bit, when I walk you through the steps, you'll see on the steps that I give you, step one is going to tell you to simplify all of the stuff that you see inside of parentheses. That obviously can be skipped in a case like this because there are no parentheses. Step two will be to clear all parentheses. And what that means is if you had a problem with parentheses and then an exponent on the outside, we would use that product property. On your notes page that I just gave you, it would be the fourth one down, where you take an exponent on the outside of parentheses and you essentially distribute it through. So those first couple steps sometimes can just be bypassed because if there's no parentheses, then that doesn't really apply, right? Yeah, so anyways, the next few examples will have parentheses, but just be advised that if there are parentheses, you need to first do any math inside of them. Okay, and then second, you take any exponents outside and distribute into them. Make sure you do those two steps in that order. Anyways, that gets us to this part. And the third step is going to be letting the top and the bottom of the fraction interact with each other. So yeah, basically what this is just a big glorified reducing of a fraction. And the way we do it is we first go and we look for things that have nothing to do with ninth grade math. We look for basic fraction numbers. So the 6 and the 8 in this problem are what catch my eye. And you've been reducing fractions since probably like the fourth grade. So when I see the 6 and the 8, that's these fellows. They have, again, nothing to do with high school, right? What can 6 and 8 be reduced to? 3 and 4, right? If we divide them both by 2. So the next thing we're going to do is we're going to rebuild our fraction, and we're going to put the numbers 3 and 4 in their proper homes. Again, just as if we were reducing a normal fraction. It's amazing how often that part can be confusing. People do stuff like 6 minus 8, and I go, wow. Like that, I get it, but like they're not exponents, right? So don't confuse like fourth grade reducing of a fraction with actual algebra exponent properties. Once we get past that, now we have to utilize what we learned yesterday. And in order to simplify or reduce an algebraic fraction like this is where you have to know your properties of exponents. And what I'm going to look for is in alphabetical order, I'm going to look for first x's because x's come before y's. And I'm going to perform the second property on your notes page that yeah. Remember, the second property is the one where if I have the same thing on top as I do on bottom, what do I do with the exponents? I subtract them. And I maintain to this day that anyone beyond the age of like 11 or 12 should not miss what I'm about to ask you to do. I take the exponent of the x on top, negative 4, and I subtract from it the exponent of x on bottom. And I'm sorry if you miss stuff like this, but well, you shouldn't be. What is negative 4 minus 2? It is always has been, always will be negative 6, right? So for that reason, watch what I'm going to do. Because the x would have come out to negative 6, here it goes. I'm going to put it on the bottom, but I'm not going to put it as negative 6. I put it where the positivity or negativity tells me to put it. But I'm never willfully going to put it in as a negative exponent. If it's negative, I put it on the bottom as a positive. If it's positive, I just stick it on the top, right? Let's do it again. This time, let's do it for the y's. So I'm going to take the y power on top, 3, minus the y exponent on bottom. What's 3 minus negative 5? It is 8 because it's really 3 plus 8. And because it's positive 8, what are we going to do? We're going to put it upstairs, and you are done. That's the sort of finishing touch normally. There will be one more step on what I have you write down, and it is that sometimes there will be stragglers. Like at the end of this problem, there could have been, say, like a Z somewhere in the problem, and the Z wouldn't have had anyone to combine with. So at that point, we go back and we grab any stragglers. And if their exponents are negative, we just move them up or down like we learned yesterday. All right. So that's how you simplify a big old algebraic fraction. So 1 down, 3 to go. Any questions about that? All right, let's go again. Round 2. So for this one, we're going to have a fraction, of course, and these are all fractions, by the way. So on the top, we're going to have the quantity of x, y squared raised to the power of -2. And then on the bottom of our fraction, we're going to have the quantity of 3x to the -4th y cubed all to the power of 2. So step 1, again, that you don't have written down yet because I haven't given it to you, but step 1 would be to look inside the parentheses and ask yourself, just inside the parentheses, is there any math I can do? There's not. There's nothing that I can mash together. Like in the top, there's just some x's and y's. They can't go together. And in the bottom, there's a number and some x's and some y's, and they can't go together. So we head on to step 2. What was step 2? Do you remember me saying it? Distribute. Clear any parentheses. You do not want to proceed with these problems with parentheses. It's just doesn't work. So what we're going to do is we're going to take and do that distribution step, and we're going to still have a fraction. So in my next line, I might as well just write another fraction and get it ready to go. What will I have on top? I'm going to take this power, and I'm going to give it to him and him. So what is my x going to be? X to the -2. And what's my y power going to be? Y to the -4. Good. You learned that yesterday, how to take an exponent and distribute it through, raise a power to a power. So the top is done. Now we want to head on to the bottom. Notice I am not moving things as I go. If you have negative exponents at this point in the problem, it's totally fine. We're gonna deal with all that in the next couple steps. So leave it alone. Don't do too much at once. Let's head to the bottom. And there are 3 entities in the bottom parentheses. So the first thing that happens is the 2 distributes across to the 3. And what do we get? It is not 6. It is 9. And we're safe to put that in this case because 3 is a positive exponent of 2. 3 to the 2, I can just go ahead and evaluate that right now while I'm here. Might as well just put 9. If it was 3 to the -2, I would say don't try it because it doesn't equal -9. Remember, it's something else. So, but if it's a simple, easy math problem, just knock it out. What's x going to be? Right here. What's that? X to the power of -8. Remember that we are not exponentiating, we're actually just multiplying. We are using exponents, but the property says that if something already has an exponent and you re-exponent it, they just multiply. They don't actually exponent-y themselves. That's a real fake word. And then the last one is this 2 goes right there to that 3. And how many y's do we get? Y to the You got to, yeah, remember, it's so tempting to say 3 squared is 9. I get it, but it is not 3 squared. The property says to do 3 times 2, which is 6. So that leads us back now to where we essentially started the last problem, and that is, let's just reduce this now. So what I'm going to do is I'm going to draw another fraction. And I'm just going to walk through it. Always do your numbers first and then your variables in alphabetical order. So tell me about this number 9. What's going to happen with him? Yeah, he's not going anywhere. He's got a regular positive exponent of 1. The only time we would ever move something is if it gives us a reason, and that 9 has an exponent, doesn't it, of positive 1. And so a number that has an exponent of regular positive 1 is like, leave me here. And he has no one to interact with at any other point in the problem. There's no one upstairs for him to reduce with. So he's like, I'm just stuck. Like, so our answer will have a 9 right there. It has no reason to go anywhere. And now we alphabetically go through and smash up our variables. And so take a look at your X's. There are some on the top and some on the bottom. And I'm sorry if you, again, I am, if you miss math problems like this, but that's a you thing. Like, you need to fix this. It's nonsense. What is -2 minus -8? Always 6. -2 plus 8 is +6. So where are we going to put our X to the 6th? On top. Very good. So we're placing things based on when we, bless you, when we combine them high to low, we place them based on whether their exponents come out positive or negative. That way that we don't have to move them again later. Just get it done. Let's take a look at the y's. What is -4 minus 6? -10. Therefore, because we said -10, where are we going to put our y? And we're going to not put it as -10. Remember, we're putting it as y to the 10. By putting it on the bottom, we're acknowledging what it would have been, basically. And again, this would be the point where you'd look around and look for any stragglers, and you go, no, there's none. So that's that. Still good? All right, example number 3. We are going to do on top, of course, it's a fraction, 3x to the 4th, y to the -2nd, all of that to the power of -1. Bless you. All over 9. So this is in parentheses, 9x to the -4th, y cubed, z to the -4th. Oops, excuse me. Change that, please. Z to the 4th. Apologies. I hope you're using pencil. And we want that all to the power of -2. So again, step 1 does not apply, right? There's no work to do. I hope you know what I mean when I say that. Like, there's nothing in that yellow oval to do. And there's nothing in this yellow oval that you can do. So that will be in the next example, and lots of them on your, well, not some of them on your worksheet. So if you can do math inside, do it first. That's less things we have to distribute to. So we're ready to just bypass that and head into the distribution step. There are 3 entities in the top. When I take the exponent and I distribute it through, what am I going to get? You can't just say -1. Like, that's not flying for me. Like, this right here is the first. What do we get? It's not -1. It is 3 to the power of -1. Maybe that's what you mean, but that's what you need to say. So the 3 gets an exponent of -1, and there it sits. Okay, don't just give me exponents. Can you tell me what to write? And then when I move across a little bit and I go to the second part, the second factor in there, that's this one. What do I get? Good. X to the -4th. And then third move is right here. Y to the power of 2, y squared, y to the 2nd. Good. Comfortable still? Okay. Bottom, we're going to do the same thing. How many entities are there in the bottom brackets? There are 4. Right. And so there's going to be a quadruple distribution that we have to do here. And what are we going to get? So tempting to say 81, and this is where you'll get yourself in trouble. That is not a 9 squared. It's imperative that you get that is not a 9 squared. And so Because the exponent of the 9 is about to be a negative, I'm not even going to mess with it. I'm going to put 9, and I'm going to put -2 as its exponent. Do not try to math that one because it does not equal 81. Not yet. Again, if that had been a positive exponent, I'd say, sure, 81, no problem. But nope. All right, let's head across to the x. I'm not drawing the little arrows anymore. What's the power of x going to be? Everybody agree? X to the 8th? We're just multiplying. Multiply pre-existing by new guy. Y to the what? Y to the -6. Good. And then how many z's? -8. Good. So we've gotten any math done in parentheses. We've cleared all parentheses. This is now the part where you need to let the top and the bottom interact with each other. And so in order to do this, there's a little bit of trickeration with this problem. So what we have to do is and I might need to insert a step here, is do you know why we cannot use the properties of exponents on that yellow box? Don't whisper at me, okay? You guys like to do that, and I just can't hear you. I need you to either speak or not speak, but commit. Try full send if you're going to talk. I love to hear your voices. Gets me through the morning. Do you know why we can't do that? It's okay if you don't. Like, I get it. Nope. 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 What allows us to do properties of exponents is when the bases are the same. Like if I have x to the something on top and x to the something on bottom, I can properties of exponents all I want. But the trouble is these two numbers that I'm about to circle in red are not the same. And for that reason, what we're going to do is we're going to just deal with them not using properties of exponents, but by just putting them where they need to be and figuring out what they equal. So first off, let's talk about the 3. Does he stay or does he go? He goes. So when we write our next step, let's all agree that we are on the bottom going to have a 3. He had to move, huh? And then what about the 9? Does he stay or does he go? He goes. Now, if you say he stays, there's something missing from what I'm trying to teach you here. Look at the 9. Why would he want to not stay? Because his exponent is negative, and things with negative exponents don't hang. If they're down, they move up. If they're up, they move down. Are we clear? So that 9 says, I can't stay here like this. You want me to be 9 squared, but I can't be where I am right now. You have to take me and pick me up and put me upstairs. So I'm going to take the 9 upstairs and make him to the power of 2, which of course now I can evaluate to be 81 because he's in his correction. So far, so good. Now, before we press on, does anyone happen to know what 81 and 3 can both be divided by? Well, no, 3 certainly can't be divided by 27, but they can be divided both by 3. I agree with that. And so what I'm going to do, before I press into the high school part of this problem, I'm going to reduce 81 and 3. I'm going to divide them both by 3. The 3 is going to become a 1, and the 81 is going to become a 27. So when I'm ready to press on, which I now am, I can commit to this and say that this is what my answer will look like. And why did I not put the 1? Yeah, who puts 1s on the bottoms of fractions? I know, weirdos. So don't do that, okay? If it was on top, you might need it to hold the fort. But on bottom, you'll never purposely put a 1 on the bottom of the fraction. That's just creepy. That's generally the hardest part. And ironically, it has very little to do with algebra. So let's head into the x's. Do the math problem for me with the exponents. I just maintain if I teach a 9th grade class that this should be quick and 100% efficient. 100%. What'd you say? It is -12 all day long. The power of x on top is -4. The power on bottom is 8. -4 minus 8 is -12. So I'm sticking an x to the 12th right there in the bottom because it came out negative. How about the y's? What is 2 minus -6? It is +8. It's really just 2 plus 6. And since it's positive 8, we're going to put y to the 8th on top. And, huh? We have a straggler this time. And the thing about the stragglers is, like I said, they sometimes don't have any. See, the X's and Y's we were able to place by just doing the math. I was able to combine them and then put the answer where I want it to be. It's like, got it, got it, got it. But the Z's, like, I'm sorry, I never had a chance to go with anybody. So you got to either decide to leave me where I'm at or move me. I'm a straggler. What do? We move him, right? To the top. Remember, things cannot be left in these answers with negative exponents. So that Z says, pick me up, stick me upstairs. I said, okay, so now your new name is Z to the 8th, and that is a completed problem. Gets a little harder. Let's go one more. Last one, and then it's work time. Top, this is going to be a long fraction, by the way, so be prepared for that. The top is 2 m to the negative third n to the 10th times 4 m to the 10th n to the negative 13th. And this is all going to be over a parenthesis set. And inside of it, we're going to have a 4 m to the 4th n to the negative third times 2 m to the negative 6 n to the second. All of that raised to the second. There's another step that I didn't mention, and you probably already would figure this out, but let's do what I've kind of already referenced, and that is, do you see the parentheses on the bottom, of course? Let's clean inside them. Right now, if I distribute that exponent outside, I have I have 6 entities that I need to distribute to. I don't want to do that. I would rather take the math that's inside and deal with it. So we're going to take this and we're going to clean it. So we're going to still have a fraction like this. And we're still going to have parentheses like this. But we're going to have less junk inside, right? So let's do the math inside. Well, we would begin on the inside with the simple little baby math, the 4 times 2. What's 4 times 2? So let's put those together. That's this guy, red check mark, and this guy, red check mark. 4 times 2, that's easy. That's 8. And then let's put our m's together by, what do we do with the exponents when we put them together like this? We add them, and I see that there's a 4 on one of them and a negative 6. What's 4 plus negative 6? Right. And right now, we're not even giving any hoots about up, down, move it, don't move it. Just put everything right now. We're not at that stage. And then for the ends, how many will we get? -1. Now, I should have, of course, specified this, but I probably wouldn't have to. Anyways, you agree that the top should also be cleaned up, right? So in any good fraction, like you want to clean the top and clean the bottom before you start letting the top and the bottom play with each other. So let's head across the top. What will the numbery part of the top be? 8. Again, 8, there's a 2 and a 4, just those normal numbers. So we're going to slap an 8 up there. How many m's will we get? 7. And how many n's will we get? Nope. -3. Right. So this gets us to closer, right? We made some great strides there. This problem has a lot less intimidation factor than its predecessor, but we've still got something to do. What is it? Distribute. We got to get that parenthesis set to be gone, right? No one's free to move about the cabin when they're locked up in math prison. So we're going to take the power of 2 on the bottom and we're going to shoot it through the 3 entities, the 8, the m, the n. So our next line going to be another fraction. The top you're just going to leave alone, so you can just copy it over. So we got 8 m to the 7th n to the -3. Now let's go ahead and distribute that exponent on the bottom. What do we get? 64. And again, I sometimes would say don't do that, but in this case, again, because it's 8 to the positive 2, I'm like, go for it. Green light, baby. Like 8 to the second is all good. So go ahead and just math it while you're there. If it was -2, I'd say don't touchy, but it's fine. How many m's will we have in the bottom? -4, because that's -2 times 2. And how many n's will we have in the bottom? And we've arrived now at the last step, essentially the end, where we just reduce. And again, the 8 and the 64 have nothing to do with high school, right? That's just a fraction that you can reduce since you were a little kid. What does 8 over 64 reduce down to? 1/8. We all agree that 8 and 64 can both be divided by 8, leaving us with, and I am going to put a 1 on top, and I am going to put my 8 on bottom. That 1 might go away. If something else winds up to the top, then the 1 will be like, my services are no longer needed here, and I'll erase it. So let's head to the m's. What is the math answer for the m's? I mean, I hear Gunner's voice all the time, and I hear Gage's voice, and I hear some answers, but I still hear like 13 silent people. I need to know you all know that it's 11. Like, I need to walk out of this room today and know that every one of you, whether you're speaking or not, knows that 7 minus -4 is 7 plus 4, which is 11. And since it's positive 11, it goes on top. I know some of you, it's just kind of your routine. You don't answer a lot, but it's important that you not leave if you don't get that. And now I can say to the 1, I don't need you anymore. Like, you would have been necessary if there was no one else on top, but I'm going to go ahead and delete you now because you're out of place now. So not needed. Let's head over to the ends. What's -3 minus -2? It is -1 because it's really -3 plus 2, which is -1. So where are we going to put our n to the 1? On the bottom. And I'm not going to put it as n to the 1. I'm going to put it as n. If you want to put it as n to the 1, it's not wrong. It's just a little creepy. The last piece of advice I have for you before we get to work time is this. Anytime throughout problems you see anything that says like a to the 0, just essentially get rid of it. Like, it doesn't need to be there, right? Because what does it equal? 1. And anything that's like times 1 is like, what's the point? So you're going to see some 0 powers in your worksheet. That's okay. Just kind of cross those. Good. Work time the rest of the day. Yeah, of course. What I handed out yesterday. We need to grade problems 1 through 8 really quick. So I'll just keep the recording going. You have the worksheets out. Yeah, let's do that right now. Yep. Let me zoom in a little bit. Oh gosh, I can zoom even more. Ooh, look at this. How convenient is that? There are the answers to problems 1 through 8. I'd like you to take a moment because I had asked you to get the first 8 done. So don't copy them down if you're not done, but assuming you did that, take a moment and grade those and let me know if you need any question answer stuff with those before we press. I had you do these 8. When you look at the worksheet now, you see why I had you stop there, because 9 is where all the fraction stuff starts. So that's why we cut ourselves off there. And that's as much as I can zoom, so best I can do for you. If you graded all 8 and you got them right, or you have no questions, feel free to right now proceed. However, I don't want to ignore those of you that might have questions. Like, if you quote unquote butchered a problem and would like some help knowing why, I'd be happy to assist at this point. feel like we should get some closure on the first 8 before we press on to the harder ones. Is there anything I can help you with?
Oh, I know. 105,
Because you did 4 times 4 and not 4 to the fourth. Big difference, huh? Yeah, right. It's confusing. It's hard to keep track of when do I multiply, when do I exponentiate. Like that's the biggest. The adding one's usually pretty obvious, but the other two, they get messed a lot. Are there any other in the top 8 that you'd like to go over with your math teacher before we press on? Number 2? Sure. Yeah, no problem. So number 2, the first thing I would do is I would take that 3 and that 4 and I would multiply them together because they're not exponents or anything like that. They're just regular numbers, and 3 times 4 is 12. Is that okay? Okay, so I have 12. And then what I would do is I would go through and I would alphabetically attack the variables. So the next variable that I see in the alphabet is A. So the first A is right there, and that's A to the power of 1. And the second A is right there, and that's A to the power of 3. And when you put those together, you have to add the exponents, and 1 plus 3 is 4. So that's where we get our A to the fourth. And then the B doesn't really have anyone to go with. And so that's why he's just attached to the end of the problem. Like this B right here is like, I got no one to combine with. So that's why we just glue it on to the end like that. Can't do that. Yeah, the 4 does not, if I wanted you to distribute it, then I would of course put it in parentheses. So if you'd seen like parentheses around the 4 and the A, like that, then go ahead and distribute. But no, the 4 does not have the exponent. 2A. It says y to the 8th over 4x to the 6th. You're welcome. Any others in the top 8? You want to close that book before you head on to the next chapter? Well, close that chapter, I guess. GB, wake up back there. Thank you. You guys good? I am going to turn the lights back on, so because it's work time. Those exponents are hard enough to read in the light. Lights are good for operating. All right, anything else on the top 8?
I don't know how sweet.
Want to go over that? Sure. So what happens with number 5 is it's really just there's first off, how many things do you see in the parentheses? This is really important. There are 3. So they're each going to get the exponent of 4. So the power of 4, I'm just going to write it on the other so I can write a little bit bigger. So we have 4xy to the power of 4. So first the 4 says, I'm going to fly in and become your exponent. So that becomes 4 to the power of 4. And we'll worry about that in a second, okay? And then the exponent flies over and says, I'm going to become your exponent. So that gives us x to the 4th. And then the 4 flies in, says, I'm going to become your exponent. And that's where we get y to the 4th. But the only math that we have to do in this case now is just figure out what 4 to the 4th is. And that's 4 times 4, 16, times 4, 64, times 4, 256. So 4 to the 4th is 256. So this part would just be 256. Sure. So when I do number 9, the first thing I'm going to look at is the fact that this 4 has nowhere to go, right? We agree with that. So like then when I do the U's, I do 3. So when I do the U's, I see 3 minus -4, which is 7. We agree. So U to the 7th should go right here since it's positive. And then when I do the V's, I just cross them out. So the final answer is right there. When you guys do problem 9, the V's just cancel. Like you could turn it into a math problem if you really want to. But one thing you've always known since the beginning of your real math career is that reducing fractions boils down to just making things that are the same in the top and the bottom go bye-bye. So like if you ever see anything identical in the top and the bottom, just cross them out. They're fine if you want to. Or you could turn it into a math problem and go like 4 minus 4 is 0. And then you go, oh, what do I do with v to the 0? And it's like, it's just 1. You don't put it in there. It doesn't need to be there, right? Okay. So, uh-huh.
Are these two like together? Y and X are together?
No,
or are they
they're
separate?
separate.
Okay. So
Yeah, I mean, I can't stress that enough. Like there's a 3 on top, there is a y, and there is an x to the -1. Like they are in no way connected or related to each other. Okay, good. So for number 10, first off, again, you and I agree. I'm sure that we agree that the 3 just stays. So the 3 just says, I'm going to hang here. And then the x to the 4th also says, I'm just going to hang here, right? Now, the thing about the y's is there's a y to the -1st on top, and there's a y to the 1st on bottom. And so what we need to do is we need to subtract them. So we're going to do -1 minus 1. What is -1 minus 1? What'd you say? What's -1 minus 1? Come on now, kid. No, certainly not 2. If you're on a number line and you start at, here's 0, okay? If you're at -1 and you go -1, where are you? -1 already, -1 more, where are you? Well, no, you'd have to go back up to get to 0. You're going down. There you go. So the fact that that equals -2 means that when we put it all together, here's our fraction. We're still going to have 3, and we're still going to have the x to the 4th. But because you said -2, we're putting y to the power of 2 on bottom. Got it? Did you guys have a question over there? First thing I would do is I would ignore the y to the zero because remember, what does y to the zero equal? 1. So there's really no point to saying on the bottom like x times 1. So what the problem, in my mind at least, what it actually says is on top, I have 4x y to the fourth. And then on the bottom, all I have is just x, right? Like there's no point in putting anything else. Do you agree with that? So I'm just you got to be a robot about this and say, okay, I'm going to do the numbers first, then the variables in alphabetical order. So I'm going to start with the numbers. And when I talk about numbers, I need you to be clear that that is not a number, right? That's an exponent. So when I talk about the numbers, I'm talking about this and where are the other numbers in the problem? Good answer. There aren't any, correct? So we know for sure that when we go to write our final answer, that there is going to be a 4 right there, whether you like it or not. Clear? Now I'm going to alphabetically go through and combine X's and then Y's and then Z's and whatever else I can find. So tell me about the X's on the top and the bottom. Yes, they do. Okay, I'm not gonna pause the recording. I need to say this out loud. Do you guys know that things that quote unquote don't have exponents? I should have said this yesterday. Do they have exponents? Yeah, what is it? It's a 1. All right. So if you want to, you can put ones on everything that doesn't have an exponent. Everything has an exponent. We clear? Okay. So you can take the math approach to these x's, Jackson, if you want, and you can do 1 minus 1, bless you, or you could just go like this and say, since you are exactly the same as you, they really just cancel out, dude. Right? Like they don't even need to be there because they're identical. And so then all I'm left with is my y to the fourth and he sits on top. So my answer, this looks weird. I don't like it like this. So my answer is just 4y to the fourth. Don't leave things as fractions if they don't need to be fractions. They just look weird. Braxton, you need help? You're fine. So no parentheses. So we're just going to go numbers, letters, 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 like up. So just first off, what do we do with the 4 and the 3? What's that? Now hold on a second. Let's go way back in time before I made everything so confusing, because that's my job as an algebra teacher is to take simple things and mess up your brain. If we went all the way back to like fourth grade and I said, okay, here's your pop quiz for the day. Ready? Reduce this fraction. What would you do? Exactly. So you would say, I'm sorry, I'm just going to leave it alone. Don't give me this multiplication stuff. You're thinking of like, if they were maybe, okay, fine. If they were on the top, right? If they were like 4 times 3 next to each other, yeah, it'd be 12. But when they're top and bottom, they're just a fraction that you just reduce. And you can't reduce 4/3. So my answer, again, I say this, that you have no control anymore over this. There's no workaround. Your answer is going to have the number 4 and 3 on the top and the bottom. Like you can't mess with that. Now let's alphabetically smack the A's. What do we get for the A's? That is correct. No, it's just, listen, if there's an exponent on top and an exponent on bottom, just subtract them. Don't read anything into it. Just take the top red one minus the bottom red one. What is 4 minus 3? It is 1. So a to the power of 1 goes on top because the 1 that we got is positive, right? And then this one is a straggler, and it just stays on the bottom.